Section 7.3 is on logarithms and logarithmic functions. The inverse of an exponential function, written as y equals b to the x, is x equals b to the y. Notice, remember, this is your basic exponential function, y equals b to the x, but then when we do the inverse, we switch our x and y. So switching x and y, I have x equals b raised to the power of y. But there's no way to solve this equation for y, so get it into y equals form. So we use something called logarithms. We say that y is the logarithm base b of x. So here's a little explanation of that. So if b to the y is equal to x, notice that's the same thing we had up here, b raised to the power of y is equal to x, that's exponential form, then the log base b of x is equal to y. We read that the log base b, and this is written as a subscript, of x is equal to y. Notice what we did. I took the base right here, so my base is the big number, big letter or number. That becomes my base. The power that it's raised to goes over by itself on this side of the equal sign, and the x is what I'm taking the log base b of. So log base b of x is equal to y. Let's try a couple where we kind of rearrange them a little bit. So here we have log base 4 of 16 is equal to 2, and I need to write that in exponential form. To do that, my base is 4, so that's going to be my big number that I write. So it's going to equal 16, and it's going to be 4 raised to the power of 2 equals 16. So written in exponential form, log base 4 of 16 equals 2 is 4 raised to the power of 2 equals 16. They mean the same thing, it's just two different ways to write it. This is logarithmic form. What I've boxed here is exponential form. Now let's go the other direction. Here I have 125 raised to the 1/3 power equals 5. I need to write that in logarithmic form. So I write the word log. My base is 125, and I say the log base 125 of 5 equals 1/3. And it's just something you have to memorize, get used to where the numbers go. So your base is down here, the exponent is to the right of the equal sign, and what it equals is the large number after the base. Okay, so here's a problem. It says evaluate log base 1/2 of 256. So what this means, actually another way to write this is I could put this as an equation. So I have log base 1/2 of 256 is equal to what? I don't know what that's equal to. So the way to solve this is to write it in exponential form. So 1/2 to the x power equals 256. And now let's use some of the tools that we learned in the last section about writing these as solving exponential equations. So 1/2 is 2 to the negative 1, and that's raised to the power of x. And now I'd like to write 256 with a base of 2, and if I try that in my calculator, 2 times 2, 2 times 2 times 2, and so on, 2 to different powers, I realize that 256 is actually 2 to the 8th power. So let's go ahead and multiply our exponents here. So 2 to the negative x power equals 2 to the 8. And again, remember, if your bases are the same, I can just pull off the exponents. Negative x equals 8, or x equals negative 8. Okay, so the trick to evaluating a logarithm like this is basically make it equal to x, and then solve that, write it in exponential form, and then solve that exponential equation. Now let's take a look at graphing some logarithmic functions. The basic form of a logarithmic function is f of x equals log base b of x. Now there's two ways to graph this. The easiest way is to kind of just memorize some of these points that we have to graph, because all log functions are going to look basically the same, or there is a way to do it on the calculator, and we'll take a look at both of those ways. So if your base is greater than 1, we're going to graph the following points. b 1 over b, comma negative 1, 1 comma 0, and b comma 1. We're just going to graph those 3 points, plot those, and draw the curve. That's probably the easiest way to do it. If b is between 0 and 1, in other words, if b is a fraction, if my base is a fraction, then I'm going to graph the points b negative 1, 1, 0, and 1 over b, 1. Now remember, 1 over b is going to be 1 over a fraction, which just means the reciprocal of that. So we'll take a look at that. If you want to do this on your calculator, you'll notice that there is a button that's called log on your calculator, but this defaults to base 10. In other words, this little b down here would have to be a 10. There's no way to change the base in your calculator using the log button. So to graph it, what we're going to do is you can do log of x, log of x over log of b, and that'll change your base. Okay, we can take a look at how you do that, but let's take a look at a couple examples here. So here we have f of x equals log base 2 of x. Since my base is 2, and that's greater than 1, I'm going to graph the points 1/2, comma negative 1, 1 comma 0, and 2 comma 1. And I got that from the little chart I had at the top of this page here. If b is greater than 1, graph these points. So that's going to make my graphing very easy. So 1/2, negative 1, the point 1, 0, and the point 2, 1. And my curve is going to look like this. It's going to continue to increase as it goes off in the positive x direction, but it's going to approach the y-axis, and the y-axis is going to be a vertical asymptote. Okay, if I want to do that in the calculator, let's take a look and see what that looks like. And I don't have my calculator open, so it'll take a minute to do that here. So we're going to put into the calculator, clear that out, we're going to do log of x, and close the parentheses, divided by log, and in the parentheses I'm going to put the number that was my base, which was 2. And let's graph that. Okay, and here's my curve. Now it doesn't quite show it getting close to the y-axis. It doesn't quite go down all the way, but it does continue to go down. Okay, and you can see from the table, there's my points. Oh, you know what? I don't have 1/2 in there. Let me go ahead and do that. Let me go ahead and put into my table 0.5. There's my negative 1, 0. Oh no, I don't have 0. There's 0. Oh yeah. Oh, that's correct. I don't have 0. Let me go back up. 1 and 2. And so there's the points that I expected would be in there. When I use 1 over b, that's 1/2 gives me a negative 1. I always have the point 1, 0, and then b comma 1. I actually think it's easier, although it does require some memorizing, is a little bit easier to do it that way. Just remember those points. Our next example, graph f of x equals log base 1/3 of x. My base in this case is 1/3, and 1/3 is actually between 0 and 1. So I'm going to use the points 1/3 comma 1. Okay, that's my b comma 1. The point 1, 0. And then remember the table or the little chart that I had up here said that we're going to use, there's b comma negative 1, 1 comma 0, 1 over b comma 1. Now what is, do it over here, what is 1 over 1/3? Well, that's the same as 1 divided by 1/3, or 1 times the reciprocal, or 3. Okay, so 1 over b in this case is going to give me a 3, and then I have the point negative 1. So let's go ahead and graph those. So negative 1/3, 1 is going to be something like that. Don't worry about it not being very exact. The point 1, 0, and then the point 3, negative 1. And in this case, it's going to go off like this. And again, my y-axis is an asymptote, and the graph approaches it like this. Let's take a look at what that would look like in the calculator. So I'm going to clear that out, and we're going to do log of x. I guess I could have left some of that in there, divided by log of 1/3, and I'm going to do 1 divided by 3. Let's hit graph. That does look like the graph I drew. And let's go ahead and put in those points that I had chosen over here, which were 1/3. Let's go to table. So for my x, I'll do 1 divided by 3. 1/3, that gives me the point 1. There's my point 1, 0. And then I also wanted a 3. And 3 gives me the point -1. So to graph a logarithmic function, you can do it with your calculator, but I think it's actually a little easier if you just plot these particular points here.